You guys have had Red Talks before. I'm sure you've had people in defense. So I work at Raytheon, that's a defense contractor, although we do some non-defense stuff. I'm sure you've had people in defense come up here and say, I want to talk to you about what I do at work, and by the way, I can't tell you anything I do at work, because it's all classified. So there's a bunch of classified stuff in defense, yes, but there's a whole bunch of stuff that we can talk about, and I can tell you about that I do, and the types of things that we do at work. I want to talk about, so I'm very lucky because I have a lot of breadth. There's a lot of different things I do. So a lot of stuff I do has to do with Iraq, with what's going on in Afghanistan, in North Korea, China, Syria, and some other, the southern border here, some other troublesome areas. So one thing that I want to make clear up front is I just want to talk about those areas and what we do on a technical level. We're not going to have a discussion about ethically, should we be in Iraq, or should we be in Afghanistan, or is China a real threat, or is Iran really going after nuclear weaponry? I don't want to have that talk. Actually, I'd love to, but that's not what this is about. So I don't want any questions about, well, why are we in Afghanistan? That's not what this is about. So you're going to have to kind of take it on faith that we've been in Iraq, we're in Afghanistan, China is an adversary, North Korea does have nuclear technology, Iran, in my opinion, is going after nuclear weaponry. I mean, if anyone thinks that Iran really is, this is my one personal opinion, I guess I'll interject. If anyone thinks Iran is developing nuclear energy for peaceful purposes, they're sniffing glue. Definitely that's not the case. Other than that, I'm not going to interject my personal view. So I'm going to talk about these trouble spots, but not just as they come up, not in a sort of ethical way. Does that make sense? Okay, so I work at Raytheon. I've got a few degrees. I've got an undergrad bachelor's in mathematics from UCLA. I've got a master's in electrical engineering from USC, and that's communication theory, which is basically like applied mathematics. And I have an MBA, a master's in business from UCLA Anderson Business School, and I kind of want to talk about that aspect of it as well. I'm really lucky at Raytheon in that I get to do a whole bunch of different stuff. So I do technology and engineering. I get to do strategy. And that includes, what Raytheon is going after, different markets, competitive assessment with Northrop Grumman, Boeing, and Lockheed. I do finance. I do a whole lot of different things, which is really cool. Because some people, you do one thing and that's what you do. I know people that have been in space systems for 40 years, working on the same satellite for 40 years. And they seem real happy, but they seem kind of, well, spaced out, for lack of a better word. So I like breadth. I like doing a whole bunch of different things instead of one thing. All right, so one of the main things that my group does and has been doing is tracking. So I have 40 people that work for me on one team and about 50 that work for me on another team. My tracking team, what does that mean, tracking? So we've got software. We've got a software suite, and we take in data. So the data could be from different sensors. What do I mean by sensors? Hello. I mean, it could be radar. It could be electro-optical, like cameras. I'm going to talk about all this stuff. It could be SIGINT. What do I mean by SIGINT? Signal intelligence, that's cell phones. So it takes in all kinds of data, runs it through this software, and it spits out tracks. Okay, tracks of what? Moving cars, boats on the ocean, incoming cruise missiles, satellites, people. So all different types of tracking. So one of the most... one thing I've done the most is called HVT, high-value target tracking. So high-value target tracking in Iraq and Afghanistan. So the idea is somebody would tip my group off that a certain vehicle, say, is a bad guy. And you want to track that bad guy through Baghdad, through Fallujah, through some of these areas in Iraq, or maybe Afghanistan, and you don't want to lose track. That's a big, big problem we have. There are a lot of problems that go along with it. For instance, I guess I'll talk about the difference between radar and EO. So radar, you guys kind of know what radar is? So radar sends off these pulses, and they come back. So when you guys were all in pre-algebra, you have this distance equals rate times time formula, right? It's the simplest word problem you can get. Well, radar builds upon that. It's obviously more complicated. So a car's moving, a radar hits it with a pulse, it comes back, and if you can measure, you know the rate of it, it's the speed of sound, speed of light, and if you can measure the time, then you can measure the distance. And as the car moves, or the vehicle moves, you can get these radar tracks. The problem with radar is when the vehicle stops, it's invisible. You have no Doppler, no movement. Okay? So one of the problems I deal with is called the move, stop, move problem. If a car's going and you've got a radar track and it stops, it's invisible. And then if it goes again, it's visible. But is it the same car? Or maybe there's a car parked and this car comes up, stop, they get in the other car, and then they go. So that's a real big issue I deal with. It's called Move, Stop, Move. Although once I couldn't think of the name of it, I called it Go Dog Go for the group of people that was kind of person. Okay, EO, electro-optical, that's cameras. Those are cameras. So that's when you actually are seeing a vehicle. So what you see on TV, like on a police chase, stuff like that. The problem, so EO is much better. We love EO because then you can see what you have. The problem with EO, doesn't work at night, doesn't work in a sandstorm, right? It's blocked. The good thing about radar, day or night, sandstorm, all weather. So the tracker takes in EO, it takes in radar, it takes in SIGINT. What do I mean by SIGINT? Signal intelligence. That's phones. Okay, so obviously you can't talk too much about that. It gets really heavily classified, but you may have a tip that a certain phone number is a bad guy. Okay, so if you can somehow pull that in with your radar track and your video track, now you've got a clean track on a car, and or a boat, or a plane, or anything you really want, and you're able to track it. So that's one of the main things that my group does is high-value target tracking. Another problem we've had in Afghanistan and Iraq is it's crossing targets. So this is a good guy and this is a bad guy. The analysts I deal with a lot of intelligence analysts. They literally call this the bus full of nuns problem, which is weird because there really aren't any nuns in Afghanistan or Iraq. So the idea is you got a bus full of nuns, meaning innocent people, and you've got a bad guy, and they cross. But you don't know if they did this or if they did that. So this bad guy, you have no idea if he went through the intersection or as he became confused with this guy, if he went like this. So these sorts of confusing events are really, really difficult to track through. So one of the things that our software does is it's got this ambiguity detection, and it's highly, highly mathematical. You really have to know some pretty high-level mathematics to figure it out, but it's basically bookkeeping. So for instance, I know one problem we have, so there's something called forensics tracking. You can track in real time, or you get all this data, maybe from a week ago, 2 weeks ago, and you backtrack. So it's called to the right of the boom. So you guys know what IEDs are, right? It's an improvised exploding device. Those are the things that have killed a lot of our soldiers in Iraq and Afghanistan, roadside bombs, those types of things. So the idea is if a roadside bomb goes off, we have no lack of data. We've got eyes in the sky 24/7. Can you backtrack all the cars that came from that roadside bomb and see where it came from? So often you backtrack, and there are tons of vehicles that go by there. But if you've got a series of roadside bombs, sometimes they all backtrack to the same house, and they've got something in common. And so we do a lot of forensic tracking. So I remember one time in particular, there was this sort of, it was a royal palace in Fallujah. They've got so many royal palaces in Iraq. And a car came out of the royal palace, and as it hit the main road, it got confused with another car, so you didn't know which was which. And then here they split, so it could have been either one. And then it split several times again. And so these poor Intel analysts, they do all this stuff by hand. They do it by hand. And so we ran this through our tracking software, and we couldn't solve it. We couldn't actually say exactly where this guy went to, but we could say it was one of 4 end spots, for sure. Couldn't be anywhere else. And so that analyst then was able to put his very limited resources on those confusing events. And he was able to solve that problem in about 2 hours, which is good because it normally would have taken him about 10 hours to do. So that's an example of ambiguity detection and crossing targets and stuff like that. So those are some of the other problems we have. There's now there's something called multi-int, so different intelligence. So I mentioned radar, I mentioned electro-optical, I mentioned SIGINT, signal intelligence, so think cell phones. ELINT, electronic intelligence, maybe something's emitting a signal, right? Maybe something's got a radar on it. There's HUMINT, which is called human intelligence. So human is maybe you get a tip. Somebody calls up and says there's a car with a license plate that ends in JCA or whatever. And that's a bad guy. So somehow you have to put all these ints together and fuse it into a track. You want to use as much as possible. So that's called multi-infusion. That's really hard to do mathematically, and it's really hard to do as far as software. But those are some of the things we do in multi-infusion to get a bigger picture. Because if you've got 3 vehicles that go into a tunnel, and then 3 vehicles that come out, are they in the same order? Are they even the same 3 vehicles? You don't know that. So we need to work in things like the color of the car, license plates, as much information as you can. Now, the other problem that we're having is, have you guys ever heard the term artificial intelligence? It's a bad word. People don't like AI. It's way out of fashion now. They call it human dimension now, at least in the business. So the idea is that you don't have enough resources for people to actually make a dent in this problem. Do you know what I mean? Like, for instance, as an example, we have millions of hours of recorded phone conversations in Iraq and Afghanistan. Millions. Do you know how many translators we have that actually speak Pashtun or Urdu or Hindi? Like 23. How are they supposed to go through all the... They can't, right? So you look on keywords, but believe me, bad guys aren't dumb enough to use a keyword like bomb in their conversation. So how do you parse through all that data? And how do you know the context? So that's what a lot of our software is trying to do now. That's kind of the holy grail, is to get software that can crunch massive amounts of data and think like a person on what matters and what doesn't. So this is something your brain automatically does, and it does it fast. So one example of this, not in terms of what I do, but in terms of like an everyday thing, so you can understand what I'm saying, is let's say you step off a curb. Let's say you step off a curb and you hear a gunshot, and a car is coming at you. Okay? What are you going to do? You're going to jump out of the way. You're just going to leap out of the way. All you care about are what's called the kinematics of the car. How fast is it going, and what's the direction? Because your mission is to get out of the way of the car. That's all you care about. If, on the other hand, same exact scenario, same car, same everything, you step off the curb, you hear a gunshot, but now the only difference is the kinematics are 180 degrees moved. Now the car is going that way. Well, guess what? Instantly your brain takes in the make of the car. It's a Chevy. The license plate, the last 3 letters were 1, 2, 3. The color, it was red. The driver had, let's say he's a bad guy, so he's got a backwards Clippers hat, let's say. And you're taking in all of that stuff, because now your mission is no longer to get out of the way. It's not a tactical mission. Your mission is ISR, intelligence, surveillance, and reconnaissance. It's to tell the police officer that shows up exactly what happened. Well, guess what? Your brain instantly sorts on that. When you step off that curb and the car is coming towards you, your brain sees all the same thing. The make and model of the car, the license plate number, the Clipper hat, everything. But it filters all that stuff out, because you don't need it for your mission, because your mission is to get out of the way. But if it's going the other way and your mission is to collect the data, now all of a sudden all those things get through the filter. So when we have all of this data in Iraq and Afghanistan, you got to filter through it somehow. It's a crush of data. They call it the big data problem. I don't know if anyone's heard it. Not a very creative term. Big data problem. We've got too much data in theater. Because keep in mind, in Iraq and Afghanistan, we own the skies. So you're flying Predators, Global Hawks, satellites, Blue Devil Block 2, massive balloons, like F-18s, F-16s. We own the skies. There's so much data, we don't know what to do with it. We can't crunch it. So that's a big issue. And that takes a lot of mathematics, and it takes a lot of computer science. Now, one thing that I've gotten into lately, I kind of changed what I'm doing lately. So I still have my tracking team, but now I direct a whole different area, and it's called EW, electronic warfare. Electronic warfare is completely different, and I've had to totally change my thinking. So electronic warfare no longer deals with Iraq and Afghanistan and areas where we have unfettered access to the skies and we can just fly 24/7. Now we're talking about China, Iran, North Korea, Syria, places where we don't own the skies and we cannot get in there because they all have what's called IADS, integrated air defense systems, and they'll shoot anything down. You try and fly a Predator into China, they're going to shoot it down. So EW is entirely different, electronic warfare. So the idea behind EW is, as you're coming into a hostile country, maybe you want to see what's going on in North Korea. Everyone knows North Korea just recently had a nuclear test, right? So you want to find out what's going on in there. So as you come in, you have to do things like jam their radars. What you would really like to do is jam their radars and not have them know that you're jamming their radars. What you would like to do is, instead of, let's say we really had to have an action with Iran, for instance, because of their